Hello all, this is Mr. G. In this video, we're covering Chapter 3, Section 5, and after today, we should be able to solve systems of three variables using elimination. So same objective as our last video, but this video is going to be a little bit different. We're only going to look at one example, and it's going to be a little bit more difficult than the examples we did in our previous video. So let's take a look. We've got to solve this system by elimination. We've got 5x plus 2y minus z equals negative 45, negative 2x plus y plus 3z equals 23, and 3x minus 4y minus 2z equals negative 17. Now, what makes this one a little bit more difficult, at least for me, is it's not as clear which variable we should eliminate. Remember, that's always the first decision we have to make. What variable do we want to get rid of? I could see a case for two variables. I could say we could get rid of either z or y. I mean, we could eliminate x, but that's going to be a nightmare trying to manipulate them so they all match up to the opposite coefficients. I don't want to do that. But with the y's and the z's, it'll be a little bit easier, mainly because we've got a 1y right there and a negative 1z. Because since we don't have opposite coefficients already in front of us, we're going to have to manipulate these equations through multiplication, just like we did when there were two variables. If we have two variables and we don't see any opposite coefficients, we have to multiply to make something that will cancel out. And what we don't want to do is cancel out y once and z with our second combination. Whichever row we choose, eliminating y or eliminating z, we're on that row. We have to eliminate that variable twice because otherwise we're going to end up with too many unknowns. It's just not going to work out. Now, I'm actually going to show you both ways to do this problem. First, we're going to do this problem by eliminating y, and then we'll do this problem by eliminating z. Now, obviously, you don't have to do this problem twice, but I want to show you that there's two roads to get to the same answer. Right? So let's eliminate first y. So let's label this A, B, and C, just so it's a little easier to talk about. Now let's see here. We're eliminating y. First, let's use A and B, I guess. A and B, but the trouble is, if I try and put A and B together as they are, y will not cancel out. We've got a 2y and a positive y. That's going to be a 3y. We want the y's to cancel out. So that means we need to manipulate one or both of them through multiplication to make them opposites, to make one a positive, whatever, and one a negative, whatever number we choose. And I think we can do that just by multiplying this number by a negative 2, that number, by multiplying that equation by negative 2. Because that negative 2 times a y will give us a negative 2y, and then it will cancel out with the positive 2y. Like I said in our last video, the math is easy here. I mean, everyone can multiply by negative 2, at least, if you're past the, fourth, fifth grade, whatever it is, whenever you learn to multiply negatives. Maybe that's sixth grade. I don't care, whatever. But the point is, that part's easy. The difficult part is choosing, okay, what are we going to multiply by? When do we need to multiply? Do we need to multiply? The decision making, that's what we have to keep track of, all right? So make sure as we go through this video, you're trying to think one step ahead. Okay, what are we going to do next? What are we going to do next? What would I do? What's Mr. G going to do? That's what you have to be thinking throughout these videos to get the most out of them. All right, so A, I'm just going to copy down. It's 5x plus 2y minus z equals negative 45. And now we have to distribute that negative 2 to everything we see in B. Every single constant, every single coefficient. So the negative 2x becomes positive 4x. I'm going to be real careful with my signs here. Negative 2y, when we multiply, negative 2 times 3z is negative 6z equals negative 2 times negative 23 is negative 46. I'm going to double check myself one more time, make sure I didn't make a silly sign mistake. Negative 46 works, negative 6, negative 2y, positive 4x. So it's positive, negative, negative, negative. Okay, very good. Now we're ready to eliminate. Scroll down a little bit. 5x and 4x is 9x. The y's cancel out, which is what we wanted. And then we got negative 7z equals negative 91, I believe. Negative 91. Okay. So far, so good. We've gone from 3 unknowns to 2 unknowns. That's a pretty significant improvement. But since there's 2 unknowns, we need 2 equations. Remember, like we said in the last video, the number of unknowns, the number of variables must match the number of equations. So now we've got to find 2 others besides A and B that we can combine. Let me see. We want to make sure y is what we're eliminating here. So let's pick B and C. Those are the two I would choose, B and C. And this time, I'm going to multiply B by a positive 4. I'm going to multiply this by a positive 4 because that will turn this positive y into a positive 4y, which will cancel out with the negative 4y. It's all about the decision making when you're doing these problems, or really most problems, if we're going to be honest about it. All right, so let's distribute and create our new equations, or manipulate them so they look new, I guess we could say. All right, 4 times negative 2 is negative 8x. Then 4 times y is just positive 4y. 4 times 3z is plus 12z. And 4 times 23, that's going to be 80 and 12, that's 92. All right. And C, we don't have to do anything with. Let me double check my distributing one more time. Negative, positive, positive, positive. Signs look good. Yep, I'm pretty sure I did that correctly. Okay, now we just copy C as it is. So it's 3x minus 4y minus 2z equals negative 17. And we're ready to combine and eliminate one of our variables. So that we get a negative 5x, y's cancel out. We get a positive 10z equals, this is a positive, let's see, that's going to be an 82, 75. I'm going to double check myself because I really don't want to mess up this whole problem just because I subtracted wrong. 92 minus 17, 75. Very good. Okay. Now at this point, what you want to check is to make sure you have the same two unknowns. To essentially make sure you eliminated the same variable in both your blue and your green step. And we did. Here we have a 9x and a 7z, and a negative 5x and a plus 10z. If you ever get to this point and you've got mixed, unmatched, that's the word I'm looking for. If you have unmatched variables, like say I had let me get a pen here. Say we had an x, and instead of a z, this was a y. That would be no good because we've got an x and a z over there. You got to make sure that all your variables match up. Undo that. And now we've turned this 3-variable system into a 2-variable system, which is, like I said earlier, a pretty significant improvement. But we've got a little work to do here. I'm going to slide this over just so there's a little bit more space for me to show my work. Hopefully that'll be fine. Actually, let me move this one over. That would be a better way to do it. That was the part of the z. I got worried I missed the negative there. That was freaky. Okay. So we have 2 equations and 2 variables, but what we need to think now is how can we manipulate these so that we can eliminate again? Because 2 unknowns is 1 unknown too many. We want to end up with 1 unknown. So let's see. We can either try and get rid of the x's or the z's. I'm thinking get rid of the z's. Or the x's, yeah, I'm going to try and eliminate the z's. You could eliminate either. I think the z's are going to be slightly easier, but if you want to do it the other way, that's fine. But here, unfortunately, we're going to have to multiply by both of our equations. Let me draw a line here just to sort of separate them. I guess I don't want it to be that long. All right, so to get the z's to match up, our goal is to get to a positive 70 and a negative 70. So that means I multiply this by a positive 10 and this by a positive 7. The signs are already different, so we don't need one of our numbers we're multiplying by to be negative because we want to keep the signs the same. This 10 times the negative 7 will give us a negative 70, and the 7 times the positive 10 will give us a positive 70. All right, so now we're going to distribute through. Multiplying by 10 is pretty simple. It's just going to be 90x minus 70z equals negative 910. That's probably going to be annoying to deal with. And then on the green side, this is going to be slightly more annoying. It's negative 35x plus 70z equals 7 times 7 is 490, and 35, that's 525. I'm going to double check myself. 75 times 7, yep, 525. And now we should be ready to combine to eliminate a variable. Let's see, 90 minus 35, that's going to be 55x. Let me double check myself. Yep, 55x. Z's cancel out, which is good. And here we get equals, that's going to be 375? I don't know. I'm just doing the calculator. Negative 910 plus 525, negative 385. I was close. I was in the ballpark. Okay, yeah. When you're doing these problems, don't be a hero, everybody. Just you've got a calculator, use a calculator. There's nothing wrong. There's nothing worse than doing like a whole page worth of work like this and then realizing that you subtracted wrong. and everything's now wrong, and you got to redo it. Just don't be a hero. Use a calculator if you need to. All right, now we divide by 55. I believe this is going to be -7, but like I said, let's not be a hero. Let's double check ourselves. Oh, I typed it in wrong. Divided by 55, not just 5. Yeah, -7. Very good, -7. All right. So we've got our first answer we can put on the answer line. X equals -7. Now, I know after all that work and only having one variable, we can think, oh, geez, are we only a third of the way there? No, we're more than halfway there. In fact, I'd say we're like 75% there because once we have one value for our variables, it becomes a lot easier because now what we can do, we can take this x minus 7 right here and substitute it in to either any of our blue or greens, any of the equations we have with just two unknowns. Let me see. I'm going to use the green, I guess, the -5x plus 10z. So let me draw a line here to separate my work. So this is going to be -5 times the -7, we already know, plus 10z equals 75, and then we just simplify and solve. So we get positive 35 plus 10z equals 75. Take away 35 from both sides. Scroll down a little bit. And then we get 10z equals 40. Divide by 10, and we get 4. So z equals 4. And we've got our second answer. Yeah, finding that second variable, that second value, excuse me, is positive 4. Finding the second value is always a lot easier than finding the first one. And finding the third one is even easier because now that we have -7 and 4, we just plug into any of our original three unknown equations, our original three variable equations. Let me see. Let's use, I think B is going to be the easiest. So that's going to be -2 times x. That's -2 times -7. That's positive 14. Plus y is plus y because that's our one remaining unknown. Plus 3z, that's going to be plus 3 times 4 is 12, equals 23, and then we just simplify and solve. This becomes y plus 14 and 12 is 26, equals 23. Take away 26 from both sides. I'm running out of space, so we'll put this here. We end up with y equals -3. Oh, that's just our answer. We could have just written it there. Whatever. Y equals -3. And we're all done. -7, -3, and 4. Let's put a box around this just to emphasize that's the answer. I don't want that times 4 in green looking like it's part of the answer. All right, so that's doing it by eliminating y first. Now let's take a look at how we can do this and get the same answer by eliminating z first. So let's jump right in. Let's do A, B, and C. And C. And again, it's all about the decision making here. So let's see, to eliminate z, I think A and B would be a good pair to start with. So A and B, but they're not ready to eliminate just yet. We've got a -z and a positive 3z. So we got to manipulate them. We got to multiply by something to create our opposite coefficients. And if we just multiply A by positive 3, that will turn this -z into a -3z, and we'll have our opposite coefficients. So I'm going to scroll down, and again, be very careful with your distributing. So 3 times 5x is 15x, plus 2y times 3 is 6y, minus z times 3 is just 3z, equals, oh boy, that's going to be a -135. Again, I'm double checking myself. -45 times 3, -135. Okay, so far so good. Now we copy B because we don't need to manipulate that at all. That will already have our positive 3z that we're looking for to cancel out, equals 23. Now it's time to combine and eliminate. Again, I feel like this is going to be a little bit in the way. I'm going to sort of keep this somewhat organized. All right, now let's see, what do we get there? It comes out to 13x plus 7y. The z's cancel out, which is what we wanted to happen. And this is a negative, let's see, that's a -110, -112. Again, I'm going to double check myself, but plus 23, -112. Okay, so far so good. Now we're going to do something similar with another pair, because again, we want to eliminate z again. We've got one equation right here with two unknowns. That means we need a second equation with the same two unknowns, the same two variables. What can we do here to eliminate z? We definitely still want a involved because that -z is going to be very easy to manipulate to get it to match. And let's multiply, or let's pick c as well because we've got a -z and a negative 2z. We can very easily multiply that negative z up top to create a positive 2z that will cancel out with the negative 2z. All we have to do is multiply by a negative 2, and that'll turn the negative z into a positive 2z. All right, so let's draw a line just to keep our work somewhat separate. Getting a little crowded. Scroll down a little bit. So let's distribute for a. So negative 2 times negative 2 times positive 5 is negative 10x. 2y times negative 2 is negative 4y. Negative z times negative 2 is plus 2y. That does not look good. Let's rewrite that so it's a little easier to see. Plus 2y. And then equals negative 45 times negative 2. That's a positive 90. And c, let me double check the distributing though. Negative 10, negative 4, positive 2, positive 90. Okay, good. I'm always worried I'm going to make a little sign mistake when I do these problems. And we're going to do the same thing for c. Well, actually, not the same thing. We don't have to multiply at all. We just copy it. 3x minus 4y minus 2z equals negative 17, and we're ready to combine to eliminate one of our variables. Let's see. We get negative 7x. The y's do not cancel out. We get negative 8y. But right, we didn't want them to cancel out. Oh, geez, what a typo there. What a typo. Let's fix this. That's supposed to be a positive 2z equals, for crying out loud. Just going to have to rewrite it. Positive 2z equals 90. Is that what it was? 90? Negative 2 times negative. Yeah, very good, very good. See, always places to make a little mistake and then everything goes haywire. So the z's cancel out, equals 90 minus 17, comes out to a 80, a 73. I'm going to double check. 90 minus 17, 73. Very good. Okay. So now we've got two equations, both with the same unknowns, the same variables, and you always want to check that at this point. Okay, we've got one equation right here. We've got an x and a y. Here we've got an x and a y. That means we're on the right track. If this had been like an x and a z, then we'd have to go back and redo the first two steps to eliminate z twice or eliminate y twice, whichever one we're doing. But you always want to make sure you end up with the same two unknowns at this step. All right, now to solve this, we're definitely going to have to multiply by something. Let's see, what does it look like it would be easiest to match up? I'm going to match up the y's, because to match up the x's, we have to multiply like this one by a 13. I really don't want to multiply 73 by 13. So let's match up the y's. So we've got a positive 7y and a negative 8y. So the signs are already different. That's good. And the lowest common multiple of 7 and 8 is a 56. So we're going to have to multiply the blue by a positive 8, and we're going to have to multiply the green by a positive 7. Not impossible, but these numbers are going to get kind of annoying. But just got to deal with it. Just got to deal with it. Let's take a look. So 8 times 13, that's 80 and 24. That's 104. I'm definitely double checking myself. I don't want to make a mistake this far into the video. So we've got 104x plus 56y. That one's not too bad. Equals negative 880, negative 896. I'm double checking myself though. 112 times 8, 896. Okay, so far so good. Now we jump to our green, and let me see what happens. So it's just going to be negative 49x, negative 56y, equals 7 times 73, that's 490, and 21, that's 511. 73 times 7, 511, very good. Now it's time to eliminate. Combine to eliminate one of our variables. Let me see. 104 minus 49, not minus 49, that's going to be 55x. 55x, 104 minus 49. Yep, so far so good. Y's cancel out, which is what we wanted. Equals, I don't know, negative 896 plus 511, negative 385. Done it completely in my head with no help at all. You all saw me. Now it's a one-step equation. One variable, to get it by itself, we divide by 55, and we get x equals 7. Oh, negative 7. 55? Yeah, negative 7. Very good, very good. And yeah, that does sound familiar. That's what we got the first time as well. X equals negative 7. All right. Now, from here on out, the steps are pretty much going to be the same. So I'm going to run through them. We just take our x equals negative 7 and plug it into one of our original blue or green. So either the 13x or the negative 7x one. I'm going to use the negative 7x. Let's use the green. So that becomes negative 7 times our x value of negative 7. Oops, that should be green. Again, colorblind teacher trying to color code. What could go wrong? Then we keep copying. So it's negative 8y equals 73. Then we simplify and solve. Multiply here, get positive 49 minus 8y equals 73. Two-step equation, subtract 49 from both sides. Scroll down. We get negative 8y equals, that's going to be 24. Is that right? 73 minus 49? Yep, 24. Divide by negative 8. And we get y equals negative 3. And we got our second value, y equals negative 3. Let's add that to the answer line, and we are just about done. What was it? Y equals negative 3. I always forget them so quickly. Negative 3. Now, we just plug in negative 7 and negative 3 for x and y respectively, and we'll be able to find z. Which one do we want to use here? I guess b is probably fine. Yeah, we'll just use b. So negative 2 times x, that's negative 2 times negative 7. That becomes a positive 14. Plus y is minus 3. And plus 3z is just plus 3z. That's our remaining unknown. Equals 23. Simplify and solve. So this becomes 11 plus 3z equals 23. Take away 11 on both sides. End up with 3z equals, just sort of carrying my work up there. 3z, oh geez, that's not a z, and that's definitely not an equals. 3z equals, that's a little bit better. 23 take away 11 is 12. Divide by 3 and we get z equals 4. If you're good enough to skip some of these steps, that's a good thing. I'm just showing all my work so I don't lose anyone. Just sort of a math teacher OCD. And we're done. So there we go. We got the same answer two different ways. Once where we eliminated y first, and once where we eliminated z first. So hopefully this was helpful, seeing how two different rows can get you to the same answer. And these are not the only ways to do it. There's lots of different possibilities. That was the point of today's video. Hopefully this made sense. If you have questions, as always, just let me know. Enjoy the rest of your day.